Hello guys, welcome back to the part 2 of understanding statistical aspect of bioequivalence study. In my last session, you have gone through the design concept of bioequivalence study, the reporting and little bit more detail about drug, what do to the body and what body do to the drug. Let's go ahead with the computing part of it. Just a recap, we have learned the generic versus the innovative drug and what is PK, what is PD. We have understand that bioequivalence concept and how we measure the bioavailability of a drug inside the body. Then the profiling, we understand what is the PK, what is PD, how we are measuring the drug concentration and how it's becoming available inside the body, and what are the parameters to represent its rate and exposure of the drug. This is the profile. We have gone through it to understand the equivalence. Criteria, we understand zero point 0.8 to 1.25 is standard criteria. This is the design part, the simple two sequence, two period crossover study design to understand the bioequivalence of test and reference drug. Hypothesis, we have figured it out. It's a composite hypothesis. We have to test the hypothesis whether T by R ratio of my test versus reference drug is less than a parameter or it's a greater than a parameter, and both simultaneously cannot be possible. Either it will be less or it will be greater, but you have to test the both hypotheses, and if both hypothesis is rejected, then only you can conclude that it's making the equivalence. So that's what your hypothesis. Toast is available to test the statistics in a pair t-test kind of concept with one-sided, but mostly we do the modeling part, and this is the model proposed. We are going with the random effect model where fixed effect, covariates, and the random component will be estimated. This is the layout which we have proposed, that how to display your result, and this is the profiling plot. This is now the computation part. Now coming to the computation, let me explain a little bit on the SAS. It was pre-opened. I will do everything from scratch. So let's go to the desktop, open the SAS. Here I got the SAS open. So once you will open the SAS, you will have three different active components. One is your output, one is your log file, one is your window where you do the coding. And then this side, this is a kind of navigation structure, like it will give you opportunity to connect your data, your PC, C drive, all the folders in this. But basically it create another library concept, SAS. So it will work with the library. So suppose I'm going to the library. These are the work library. Anything you do will store in the work until unless you specify where physically it should be stored. Sorry. And once you will close the SAS session, sorry. And once you will close the SAS session, this whole data which you will work will be gone. So it's always good to create a library where you physically store your data. And how to do that? You have to write a small code like lib name, and then SAS lib for work. This is small, try to be very small. So SAS lib I'm saying, and then you have to give the path. So suppose there is a folder on my desktop SAS work. So let's see what its path, and I have copied the path, close SAS. I have pasted the path here, comma. Let's run it. I have selected and run it. So it's saying that library saslib was successfully assigned to the following path. Now anything I will store here in saslib will be basically going to permanently store here in this folder. That's the library concept. Now coming back to the working on SAS, I have already pre-stored the file, text file where I have written all the codes for that. Let's open that desktop, and then I have PK testing. The file program file is open for me now. Let me try to explain how it's structured. So there is no data. I am creating the data, and that's the beauty of the statistics. Once you know the distribution, you know the pattern, how things are occurring, you can fit a close distribution to that, and you can generate the data simulated way. And you can do a lot of research with the simulated data and try to have some initial conclusion from that, and then finally you must have a real data to test your conclusion, because these are the simulated data, assumption based, and assumptions may be valid, may not be valid. So let's see, our design was two sequence, two period, crossover study. So I have a 50 subject. I am randomizing them in a two group, subject 1 to 25 in a sequence 1, 26 to 50 in a sequence 2. Now my sequence 1 is RT, that is the sequence. So RT means R and T, and R is for period 1, T is for period 2. And in both the period, I need AUC information. Similarly, I'm doing for Cmax. And then what I'm doing, I'm putting their parameter value. What value is coming from normal distribution for variance, I mean mean this and variance this, something like that. So this is log transform data just for assumption purpose. And similarly, I'm doing for 26, but here my sequence is TR. So first T, then R, and again period 1 and 2, the same parameters, and with certain different in their mean and variance, I'm simulating this. Let's run this data. I've run, come to the log, check what it's saying. Okay, so it's saying that uh, this data has been run, the dataset work, that parameter has been created. Why it's saying work dot? Because I didn't specify any permanent library. I just run it, and it was stored in my work library. So let's go to the library. So back here is my work. So see, here the data is created. Now see all the subjects, subject 1, 2, 3, 4. Each subject should have two parameters. So each subject first, this is subject in sequence RT. RT has RT, RT. Then R stand for period 1, T stand for period 2. And then in each period, AUCT and Cmax is created. Their value is created in that value data set. So data is perfectly created. Let's go for the further. So SAS is working with the structured data. So my data need to be sorted as per the bivariable I am using in the model. So let's sort the data. Done. Now I have to give some option like where my result need to be stored. So I am giving ODS RTF. So I am asking SAS that my result need to be converted into the RTF file, and it should be physically stored at this location by this file name. That's what option I have given. And then my whole code of the model, and then basically I have to close that RTF file. So ODS RTF close. Basically RTF will be closed, and this statement will allow you to open the RTF by default. Now what I'm doing in the model, is my mix model, plugging the data using method equal to REML by parameter class means specifying that which variable is nominal, my model statement, which item is random effect in the model, estimating the least square for the treatment, and then estimate statement from the model. I want to estimate certain things at certain value that can be facilitated here, and then ODS output means I want to create a SAS data from the estimated output of this model. So my estimate will go in EST, my LS mean will go in LSM, covariance parameter will be in COVE data. What I am requesting in the model is my confidence limit, residual, covariance, correlation. This is co-RR means correlation, covariance, solution for the fixed effect. I am specifying that for degree of freedom use Canvas-Roger approximation, and I'm asking that you predict the output and residual data set. That's what all I'm doing. If you want to know the more detail about how the SAS is doing, the authentic way is to explore it on the SAS support website. What you have to do is, let's say, uh, how I used to do, I ask SAS, means just do a Google SAS ProcMix, and it will give you a lot of site where you can find the information about ProcMix. But you search for the SAS support website, support.sas.com, and then you see HTML. Here sometime it's PDF, so it will directly give you a PDF file to read. I always prefer the HTML way, so I used to go here. Now it will say that what you can do with the SAS mix model and what ProcMix is doing, all the options. So just go one by one. It will give you the theoretical concept of the mix model, then how the syntax should be written, then some detail about the methodology, and couple of example how they have executed the mix model. So how to write the syntax, I used to go here and see that what are the syntax for the mix model using in SAS. So it is proc mixed, and then okay, if you click on the blue icon, it will hyperlink, it will go to the more detail about that option. So SAS syntax is proc mix, then option, then by class id, model, random, repeat, param, prior distribution you can also plug in the modeling, contrast, estimation, ls mean, weight, and then end, like run, and you can do. Now beauty of this support website is anything you want and you are not sure how to write the code, it will provide you help. So let's see, I'm going proc mixed and how to write. So proc mixed, I'm clicking. It's saying that, okay, proc mix has a syntax like proc mix, and then you have to write your option. What option I can write? It's saying that first option, basic option, you have to give the data. Then which method you want to estimate. Then profiling, order, and so on. Then these are the options which will control your display output. This all you can give here. It will control your display output, which output to be displayed, which output not to display. And then these are the some optimization options which you will give, that how to do the estimation. And in the computational options, you have to specify like which method you want the computation need to be done by the SAS. And if you want to more detail, like okay, suppose I want to see that what COPE test means and what it will do, so just give the COPE test. Now you say the COPE test is the product asymptotic standard error and word jet test for the covariance parameter state. So once you will give that option, it will basically do for your this stated text. In many way, it will give you more theoretical detail, like which option will do what kind of computation and what are the formula, what are the method of estimation for those statistics. Suppose in the presentation you have seen here that I have used method is equal to type 3, but in the text I am using here method equal to REML. I've intentionally done it to demonstrate you a couple of options, like there are many methods available to compute the mix model. Every method has a different merits, demerits, and based on your need you have to customize it. But here I am using restricted maximum likelihood method. Now if I want to know more detail, like what methods available in SAS to do and what they are performing, again I'm going to the sassupport.com. I'm going to the mix model statement. I will search for method. So here is the method, and it's saying that you can write maximum restricted maximum likelihood estimate, maximum likelihood estimate, minimum variance, unique unbiased estimation, something like that estimate, type 1, type 2, type 3. And all those type of estimation process has different way of doing the variance and other estimation process. You can go more detail, and other options which you can use, it's giving the theoretical component of it so that you can check what really you need. In this model statement, suppose I want to see what these are doing and the way how we are doing. So 1 minute. I would like to put your attention on the variance component also. So if you are using a random effect and then you are not sure how your variance component will be done, which variance component is basically going to give you that what you need, then you have to search for it, that which variance component may be appropriate for you theoretically, and you have to figure it out the code which is exactly for using that variance component. So uh, by default it's using the variance structure is variance component. If we use this, let's run one time and try to figure it out how the result is generated. I'm running, the model is running. As I told that it will give the output in a word which I have instructed. Here is your word file is open. After running the model, I'm minimizing it for the time being and coming to the result window of the SAS. He go to the navigation, see here pick a parameter, model information, see. So it has given that pick a parameter data has been used, this value is analyzed, and covariance structure it's using variance component. Okay, this is what I would like to see. But my data here is very much structured in a very symmetrical fashion. Okay, so I can use compound symmetry also as a covariance structure. But be sure, if you are going to use a different kind of variance structure, it is going to over parameterize your model and so the estimation process, and your degree of freedom will be accordingly adjusted. Variance component is having the highest degree of highest level of parameters, and no, sorry, variance component is going through variance, but there is another variance structure that's called unstructured. So unstructured variance component will give variance to the every parameter, and it's the highest level of parameterization. So until unless you have such a rich data to handle estimation of so many parameters, don't use the unstructured. But if you really don't know about the structure of your data, then there is no other options. You can go ahead with the unstructured. Now, little bit theoretical concept if you would like to know, then again I prefer to go with the sassupport.com and try to see that in somewhere model information is there a type, like which kind of variance structure I can give. No, it should be in random. So okay, here you see when I'm giving the random option, then it's giving me the option to choose your variance structure. So type is specify the covariance structure. Let's go. Now what it's saying that type the covariance structure, and how many type of covariance structure I can have. So you can choose it from the uh, actual data. It's saying that type equal to VC, that is the variance component, it's the default one. But you can type equal to unstructured, that is really you don't know your structure, and then you can go ahead with the unstructured data. Then you have a certain different level of FA02, and which request the geometric estimation, non-negative, definite, all those kind of estimation process. Each detail of what we do, what VC do, variance component, what is unstructured do, it's more detail you can find it out. How the actual variance component has been created, all those things. And similarly, if you have a confusion about any options here mentioned, like what is residual, what is covar, all those things, you can search in appropriate option. Like see, here I have written a pdiff statement in a ls mean. What it's going to be do? Okay, let's see. I have to navigate to the ls mean. So here ls mean, and then in the ls mean it's saying that you can write the options. So options here are these. Now diff here. So diff is the option request a difference of ls mean. That's what I have to use. Now pdiff is something probability also computing and p value computing for the diff statement. So this is the diff. and pdiff. See, it's giving both option you can use, pdiff or diff. This is request the difference of ls mean to be displayed. And what should be the syntax? This is writing exactly the way you have to write. In that pdf you can write a control option also. So here I have only treatment 1 and 2, so there will be only difference. But if you have so 4 5 treatments and every treatment need to be compared with the first reference treatment, then I have to write a control option here, like diff equal to control 1. It means that every treatment will be compared with the first treatment. Otherwise what will happen? All permutation combination of the difference will be executed out, and unnecessarily you have very large data set and outputs to be read and investigate. So that's all the way of learning the syntax and programming in SAS, and how the statistics has been requested, what are the exact syntax and where it need to be put in the syntax at the time of execution, so that you can get the result out. So the answer is support.sas.com. Here you will get every solution for your programming need and or learning need in the statistics. So I have requested estimate ls mean covariance. Let's see where. So first of all, I didn't given any permanent library, so it will be stored in my work library. Same thing you can see from the log. When I run here, what it's saying, let's read the log. So it's saying that proc mixed run, and then it's going to write that in the HTML body by default. Above I have requested ODS RTF, so it's going to write in RTF. So it is going to display you two results. You can see here in the result navigation, the same information display here in HTML and the same information in the Word file RTF. Now again in the log file, it's saying that all your text has been read. Then note, convergence criteria met, but the final Hessian is not positive definite. So the theoretical statistician may have a better understanding that once the final Hessian is not positive definite, what kind of implication it will do in your computation and estimation. And then for the variance, asymptotic variance metric of convergence parameter estimate has been found to be singular, and generalized inverse was used. So couple of time when you do the modeling and approximation, if your metrics turn out to be non-workable for the further mathematical operation, it will shoot an error, or it has options to choose. So sometime it has a default mechanism to handle and it will display you the result, but sometime it will just shoot a error. Then you have to adjust the matrix design and the way forward of the approximation so that you can handle the data. Now every single detail it's displaying you while estimation, and then it's finally run, no warning, no error, and it's saying that your work dot covariance, your work dot ls mean est data created, it has 4 observation, that much variable, done, every single detail. So now go to the data. Let's see how my estimation data looks like. This is my estimation data, parameter, treatment, comparison, estimates, standard error, alpha value, lower and upper. Okay, here is my ls mean. Okay, results, done. And just go to the result also one by one. Data is properly generated. See here the model information, then data information, whatever I have specified in the class variable, it's displaying. There is subject ID having 50 subject, label is this. Treatment having 2 treatment, R and T, period 2 period, 1 and 2, sequence 2 sequence, RT and TR. Now dimension of the data when it's used for modeling, number of observations, iteration history. So when you run the model, it will iterate for approximation and it will search for a convergence. And if convergence occur, then only it will start estimating. Otherwise, the estimation won't be possible. So it's saying that it's very soon in first iteration itself converges, and then some display on the covariance structure, their estimates. Fit statistics, how my model has been fitted. So this is -2 log likelihood is 66.6, AIC, AICC and BIC. which is smaller is the better. So from here also you can choose that whatever model you are using, which should be the best model, and if you want to further develop in the modeling, what should be the strategy, which variable to remove, non-remove, or like that. Now, solution of the fixed effect. So since I have requested solution, see here in my model, I have requested here solution. So it's giving the solution of the fixed effect, intercept, treatment, period, sequence. Everything occurs twice. Why? Because SAS is dealing with the data and one is the base. So compared to the T, how much R will affect, and that's the beta coefficient actually. So that much time the R will be compared to the T. In period like 2 it is making base, so compared to period 2, this is the beta coefficient for period 1. Similarly for TR and RT, all those things you can see. Significance also you can see, whether this variable means this uh, effect is significant, not significant, their p-value you can see here. Okay, nothing seems like here anything significant. I have requested the covariance matrix also. See here in the text, this is covariance matrix. So it's displaying the covariance matrix uh, for all the variables which I am plugging in the model. And correlation matrix, I have requested correlation also. So core B correlation matrix, that's why it's displaying correlation matrix. Then test of the fixed effect. So it's treatment, period, sequence, and as like you do in the ANOVA table and you do the F value and F statistics, that estimate is here. Because I have requested type 3. So type 3 work exactly like ANOVA, and basically it's an ANCOVA. So type 1, type 2, type 3, there are 3 different methods where you can try to fix your ANOVA modeling one way, two way, the way you want to do. Then estimates. So I have requested my model to do some estimation for me. So it's estimating, and I have given the matrix for treatment. So this is actually 1 minus 1. So it's going to estimate treatment first minus second, and that's the way. This is the label which I have given. So nothing to do with the SAS, what I have written here, it will directly display there. So this is the test versus reference. I have label, it's estimated value, standard error, lower upper confidence interval. Now least square mean. So you got the estimate, you got the lower upper, and then there is a difference of least square mean. Why it's coming? Because in the least square mean I have requested difference statistics, and then the confidence interval. So see here, it should be exactly the same. So estimate is this one, my least square estimate matching. This is the same, but here I do not have match. This is something different. Why this is? Do you have any idea? Yes, it is because I have requested a different alpha here for the confidence interval creation. Okay, so in LS mean it's giving me 0.5, but in test versus reference confidence interval it's giving 10% alpha, and accordingly the confidence interval created. That's why the confidence interval is different, and that's intentionally asked, so you can customize it. You can see the same here. Once you open your LS mean, you see here your alpha is 0.005, but if you open your estimate, see here your alpha is 0.1. You got the difference? Your data is also saying the same. So whatever you need, that's again depend on you. The label, everything you can customize here. We got the data, but the thing is like we have requested that this should be the output, but my result is not like that. So good with the SAS that you can get your result in a data set. So I have requested SAS to get my result into the data set EST LS mean cove, and I'm going to further work on that. So first of all, every estimate is in the log transform data, so I have to get it back on the original scale. So I'm doing the exponential of it. This EXP option is getting it is into exponential, and then I basically need the parameter, treatment, label, estimate, low and high value. So I'm keeping these only the variable, rest all I want to be omitted. So I'm running this similarly for lsmin, run, and basically let's do it. I run. What happened? Go to the log. It's shooting a lot of error. Why? What it's saying, you cannot open work LSM data for output access with your member level control because your data is in use. I have used this data. I have opened this data. So until unless I will close this data, it won't work. So let's close the data, whatever I have opened one by one. Okay. And then rerun. So rerunning. Now what's this thing? Yes, perfectly run. There is no error. So both code has been run. Okay. Let's see what happened. This is my LSM. Everything is work as per my text. Transform, estimate. Yes, it's work and transform. So now merge these two files into same single file. So I'm creating a file final. See the log. Yes, no error. Final data created. Okay, now it looks like little bit the way we want to display the result. So final doing the reporting. We can do title, footnote, and many more thing here. So see, this is one thing. I have closed my RTF here. So now this result won't go in RTF. Okay. But if I want my this result to be go in the RTF, I may have closed my RTF here. So this result also may have went to the RTF file. Just running this, it will come to the HTML output, and see, it's looking something like what we something like what we have requested. So my PK parameter, treatments, adjusted geometric mean, standard error, ratio, lower upper confidence interval. And that's exactly the same thing went to the presentation here where we have conclusion. Okay. So this is, see, that's where we cross the boundary, and hence my study, the simulated study, was failed to demonstrate the bioequivalence. And this is all from my as part 2.